Learning goal today, you come over here with me to this. I can solve a proportion. We've been doing that for a while now. But today we're going to need to use that cross products property because it's going to be, otherwise I'm not sure that you'll have an understanding of how to solve them otherwise. So we're going to use the cross products property that we've already learned, and I can check my solution. So today you are going to do check problems for these to make sure that you have a good solution, because today it's not going to maybe be quite as obvious to you whether you have a good solution or not. So the reason that these are just a little bit different is we are going to be solving proportions that have more than one term in a numerator or a denominator. So in other words, it isn't just going to be a one number or one variable. There might be something being added together, something being subtracted in either a numerator or a denominator. So what we're going to do is that one that has more than one term, we're going to put that expression in parentheses. And this is really important that we do this. So we're going to take that numerator or that denominator that has more than one term in it, more than one piece to it, and we're going to put it in parentheses when we're setting up our cross products. And in reality, it might even help just to do it right away so you don't forget to do it. So in number 1, let's look at that. Which of those, we have a proportion because we have a ratio set equal to another ratio. Where would I think that parentheses should go around which numerator or which denominator in this one? Adam?
The x plus 10.
The x plus 10. So the first one's denominator has more than one term. So this is the one that would need the parentheses around it. So should we just stick them in there? You know what? We probably shouldn't. Take that out. Take it out. Because you know what? They're not going to look like this in the book. They're not going to come with parentheses in the book. So when you look at your notes, it's going to be confusing. Okay? So let's do this instead. Let's just say when we are setting up our cross products, that's when we're going to insert our parentheses. So what's one set of cross products in this problem? What would be what would be the multiplication on one of the sides?
8 times 6.
8 times 6.
Please send the following students to the senior high math lab: Devin Ward, Paul Blondal, Samio Abdi, Bryce Benton, Savannah Drake, Bobby Elstrom, Kiana Gill, Xander Johnson, Jacob Meyer, Jace Olson, Everett Peltier, Luke Ploggins, Owen Ploggins, and Justin Roswick.
And our other cross products would be what? The other, and here's what I'm going to suggest we do. We're going to take the one that doesn't need the parentheses. We're going to let that one be first, okay? So the 1 is going to come first, and then here's where we're going to put our parentheses around the other factor, that other one we have to multiply by. Now we're going to insert our parentheses. Okay, now we can start doing the things that we can do to get this close to being ready to solve. Okay? What's 8 times 6?
48.
48. What's 1 times x plus 10? We're going to have to do what's called distributive property to get rid of those parentheses. Why do we put parentheses if we're just going to get rid of them anyway? Because we have to make sure that both of those pieces get multiplied by that 1. So 1 times x plus 1 times 10. Let's just show what we're doing so that we have good, clear notes here. Okay, 48 is going to be 48. There's no reason to rename that. 1 times x is 1x. 1 times 10 is 10. Okay, we are finally ready to solve. We really have just now been using the cross products to get it so it's in friendly form to solve. So now we're really ready to start doing that. Whatever we do to one side, we do to the other side. So what should we do in this one? We need to subtract 10. Yeah, the x's are on the right side. That's what we want to get alone. So we're going to get that 10 out of there by subtracting it. And now we should have, what's 48 take away 10?
38.
38. And what is left on the right side? 1x. Okay. Now what?
Divided by 1.
Divided by 1. Okay. So 38 gets divided by 1, and 1x gets divided by 1, and we end up with what?
38.
38 for our x. So we'll circle that as our solution. 38 is our x value in this problem. Okay, so we have to show doing cross products first of all to help set us up for an equation that will help us be able to solve it. And now we're going to do a check problem. So when we, and what did I say? Are the check problems optional? Are the check problems optional? No, they're part of our learning goal today. I can check my solution. So now we're going to take our proportion and we're going to write it down as it started in the first place. We're not solving now, we are checking. Would you put a box around that word check? We will not follow the same steps in our checking as we necessarily did in our solving. We're going to, we're going to substitute first of all. So the 8 stays 8. We're going to substitute that 38 we got for x in, and 1/6 is going to stay 1/6. Now, when we're going to move on, we're just going to add that 38 and that 10, and we're going to end up with 8 over 48. Now is when you have a couple of options. Now you have a couple of options. And you can say, what do I have to do to this 8 to get 1? What would you have to do? Divide by 8. And if you divide the upstairs by 8, you got to divide the downstairs by 8. Or we could just do cross products. Remember, that's another choice. And make sure that we end up with a true statement. So I'm going to do cross products. I'm going to take the 8 times the 6 and the 48 times the 1. What is 8 times 6? 48. Notice we're not solving, we're just, working our way down here. What's 48 times 1? 48. Do we have any more to do? We ask ourselves, is this true? Is 48 equal to 48? Does it check that? Yeah. If we end up with a true statement, it checks. If we end up with a true statement, it checks. Now, if you're going to do it the other way, you want to do instead, you want to say, I want to do this. I'm going to simplify this fraction. They both are divisible by 8, so I'll get 1/6. Then I can say 1/6 equals 1/6 because that's what's on the other side. I can say it checks. So you have that option also. Can you simplify the one fraction to become exactly what the other one is? Or you still end up with a true statement. I typically myself like to do the cross products thing. Okay? Sometimes those fractions get so big and then you're like, I'm not even sure what I could simplify it with. Anybody have any questions? So this was an or. That was, if you wrote it down, that's an or. That's your other choice. If that's, appeals to you. Okay. So what could be our first set of cross products we could set up in number 2? Your first set, Blake? Okay, and what did I suggest we're going to do when we have the one of them has to go in parentheses? Which one's going to go first? The g minus 3 or the 4?
4.
The 4. We want the numbers that's just by itself to go first, and then we'll put the g minus 3 in parentheses. Okay? So we have 4 times g minus 3 in parentheses. And what's our other cross products tell you? 5 times 7. Okay, what do we have to do on that left side? We're not solving yet, we're just getting ready. What do we have to do on the left side? What's that property called that gets rid of those parentheses? Distributive property. So we're going to do the distributive property over here, which says take the 4 times the g, bring down your subtraction sign, and take the 4 times the 3. In sticking with though, you know what, we need to stay with this and just keep in the same habit. We're gonna change this subtraction in here to add the opposite. Okay, we're gonna make that G plus a negative 3. Add the opposite. And then that means here it'll be an addition, and 4 is gonna get multiplied times a negative 3. Okay, will you make sure that you have that? The G minus 3, not only are we gonna put it in parentheses, but we're also gonna change it to add the opposite. And then we're going to do our multiplication, 4 times G plus 4 times negative 3. On the other side, we can just multiply right away, can't we? What's 5 times 7?
35.
35. Okay. Okay, go ahead and get the left side cleaned up a little bit. What would that end up looking like after you do your 2 multiplications? Seth, what do you get on the left side?
4G plus negative 12.
Yeah, 4G plus negative 12 equals 35. Think there's anything else we need to do, or are we ready to solve do the same thing to both sides? Is there anything else to do, or are we ready to do the solving part now? What do you think? We're ready to solve? Okay. That's going to be our first step of solving then. Andrea? Add 12. So we're going to add 12 to both sides. A negative 12, so we're going to add its opposite. Add 12 to both sides. And what do we end up with?
23. 47 for the 35.
4G equals 47, right? Okay.
And then you would divide 4
Divide the 4.
on both sides.
Divide both sides by 4.
Yeah.
Divide both sides by 4. How do you feel about that? Does 4 go into 47 nicely?
No,
No, not a whole number of times, does it?
it goes to 11.75.
Okay. So in other words, you can take 11 4s out of 47. What is 11 times 4? 44. Well then 44 up to 47, how many units is that? What's the difference between 47 and 44? 3. So what we really get is if we're trying not to use our calculator, we say, oh, you know what? 4 can be taken out of there 11 times with 3 left over, so I end up with 11 3/4. But when we're checking, it's going to be a lot nicer to use its decimal name because this has a nice decimal name. And Adam said it. What is it?
11.75.
Yeah, 11.75 is its decimal name, which actually makes it easier to check. But we also got to know that in an answer bank, 11.75 could also be named as 11 3/4, right? But for checking purposes, 11.75 is going to probably be friendlier. So now we're going to go check it out. We think we know the solution. So we're going to write down our proportion that we had to start with. Then we will substitute our solution in for that G. Everything else stays what it was. And what's $11.75? Take away $3. $8.75, or 8.75, 8 75/100. So all we're going to do is that subtraction there. And this is definitely one where, you know what, trying to simplify that fraction, 8.75 over 5, is that going to be much fun? No? So this would definitely be one that the cross products in our checking would work probably better. And I will let you use your calculator, so if you don't have them out, go ahead and get them out. We're gonna do 8.75 on one side times the 4, and we're gonna do the 5 times the 7 on the other side. So we'll set up our cross products, and then you can use your calculators to see what happens. What is $8.75 4 times? Well, let's see, $8.75 $8.75 plus $8.75 happens to be $17.50, but I need a couple of those. $17.50 a couple of times, I think it's $35. Does it multiply to be 35?
It goes to 34.8.
It better not. We don't, I don't think it should. 11.7, or 8.75, I mean, times 4. What's 5 times 7? Why? Because you want it to be, or because it really is? Because the other side is, or because 7 times 5 is 35? Because it really is 35 over here, isn't it? And now we can say 35 does equal 35, so it checks out. We're feeling good about our answer. Okay? So anybody have any questions on these first two? We're going to do one more together, and then we're done. Okay, let's go to the back side then. Ooh, this has got a couple of them that have more than one term. So is that going to change how we're going to go about it? Not at all. We're still going to do cross products. So what would be one of our cross products? What would be one of them?
5.
Sydney?
X plus 2 times 5.
Okay, so remember we're going to put the 5 out front though, right? Okay, and we're going to put the x plus 2 in parentheses. And the other cross product, Preston?
X minus 2 times, or 3 times x minus 2.
Yeah, we're going to let the 3 be first because it's by itself, and the x minus 2 is going to go in parentheses. And what else are we going to do with that because it's got subtraction? Add the opposite. So we're going to change this one to add, and what's the opposite of 2? Negative 2. So that becomes a x plus a negative 2. I'm going to write that a little bit better. Okay, so our x minus 2 became an x plus a negative 2. Okay, now we can do our distributive property, right? So we got distributive property to do on the left side. So we have 5 times x plus 5 times 2 on the left side. We have distributive property to do on the right side also. So we have 3 times x plus 3 times negative 2. I want you to do your multiplications. There's 4 of them there to do. I want you to do them, and then I'll call on you to see what it would be. What's the result? Okay, Adam, you got the result for us yet?
Which way?
Okay.
3x plus negative 6 for the, yeah, right there.
Okay, this is a negative 2 there. Okay, I forgot to write my negative here. Did you guys remember to write your negative on that 2 there?
Yeah.
Okay, 3x plus what? Negative 6?
Yeah.
Okay.
And then equals 5x plus 10.
Okay. Everybody agree with him? We can move on. Okay, are we ready to start solving? Okay, so let's get busy and start solving now. We have x's on both sides. What do we do when there are x's on both sides? We need to get rid of them on one side or the other. So what suggestion do you have? Subtract 3x. Okay, so if we subtract 3x, it'll get rid of them on the right side. But if we do it there, we have to do it over on the left side also. Our goal is to get rid of them on one side or the other, and that happened. So now what does our left side read, Seth? What's the left side read now? 2x plus 10, okay. And Samuel, what's the right side read? Negative 6. Okay, go ahead and finish this one. Finish solving it and see what you get for a solution. Don't use your calculator now. Come on. Calculators are for when we, really need them. This is not a really need them. We're going to check it, but would you just decide if you agree with me right now? See if I think I'm right, or you're right. Who's right? Maybe both of us are. Okay, so I got -8, so that's what I'm gonna check. Did you guys get anything different? Okay, so let's go ahead and check this problem. We're gonna start with our our proportion, the way it started. And then we're gonna substitute into it. This time we have 2 places we have to substitute in, don't we? We have to take our -8 that we got and put it in for x in both of them. And again, we still aren't needing our calculators for this. We know how to do -8 take away 2. We could change this to add the opposite, and that would become -8 plus -2. What is that? -10. So this becomes -10 over 5. What's a -8 plus 2? -6. And that's over 3. Okay, so we got, a variety of things we could do here. We could simplify fractions and see if they match. We could do cross products. What should we do? Let's do our cross products maybe? So -10 times 3 on one side and 5 times -6 on the other side. What's -10 times 3?
-30.
-30. What's 5 times -6? -30. Okay, and so we can say it checks. Now again, here's the thing that I'm always, I want to caution you about. Do not just assume that the other side will be what you got on the first side. You need to actually multiply it out and make sure that it comes out to that. Not make it come out to that, but does it come out to that, okay? So check problems cannot help us if we're not really doing them all the way through properly and then checking to see, and then verifying that we do have a true statement. Okay, we're stopping here. We're not going to do 4 and 5 today. We'll do those tomorrow. So don't put those notes away. Keep them out. Get out your loose